that experiment where, so you have your notes out and your sheet of paper with the experiment plan on it, where you became hotshot pharmaceutical biochemists who think they've come up with the pill that cures COVID-19. And you were doing good. I was impressed. You had, I think you told me you wanted 100 college kids, right? So you had a large sample size. We figured out that you can't just give them all the pill, right? Because then you have no basis of comparison for whether it worked or not. How many do you give the pill? You give half of them the pill, half of them not. Cool. Now if there's a difference, maybe we can start to figure out if it's because of the pill. We said that we wanted a lot of things to not be different. Besides them getting the pill or not getting the pill, we wanted them to be around the same age. We wanted them to have had COVID for the same amount of time. What else did we want to be the same about them? What other variables are you managing? Do you remember? Or do you have more? Yeah. We want them to be eating the same stuff. Absolutely. Anything else? In the same place? Yeah, that's helpful if you can control where they're at. Yep. Yeah, timing is super important because most people get over COVID, right? It's not about, it's not about whether they get over it. It's about, well, what are the two things you're going to be measuring to see if your pill worked? What do you want to know about their symptoms? Mikey? Changed how? Like if my pill group does what, I think maybe it's working.
I could guess like difference in their temperature or something, like whether the fever goes down or.
Put you on the spot. Sorry. What's a good way to say it? What's a good way to say we want to see if the pill group what as compared to the non-pill group? If they get better faster. Is there anything else you want to measure about their symptoms? Death rate would be good if it was lower in the pill group. Hopefully the death rate is very low in both, but we'll see, right? Any other way you can describe this? We want the duration or length of their symptoms. We want to measure that to see if it's different. But isn't there something else about their symptoms you want to measure? How about how bad they are? How severe my pill group symptoms are compared to my non-pill group, because that's super important too. If it's just the same length, but your symptoms are way easier to take, way less, let's say, lethal, that would be a good thing. That would mean my pill's working too. So let's say duration and severity. Good? All right, not bad. That's not a bad experiment except for one really important thing that we'll address afterwards. But we have enough right now to kind of identify the parts of a typical experiment. With any experiment, and this, by the way, is what you've kind of been taught is the scientific method. What it really is experimental design. This is where you start writing in your notes. Experimental design, or the scientific method, it's a scientific method. It's a very powerful one. It's not the only one. Is simply a way to test something you think might be true. Or not true. We call that the null hypothesis. We'll talk about that later. Sometimes you're taught that a hypothesis is just an educated guess. I don't like the word guess. Usually if you've got a hypothesis, it's at least more of an educated opinion. You at least know something about your field. And so any experiment, and this is going to be the bulk of your work for the next couple of days, you're going to want to be able to identify certain things about any experiment. And the first thing is there's 3 types of variables in any well-designed experiment. Raise your hand if you remember this, kinda. I won't put you on the spot. Raise your hand if you remember identifying different kinds of variables in an experiment. 1 or 2. Okay. Variables are just things that change. But very distinctive types of variables you ought to be able to distinguish between in any experiment by the time we're done here. Who remembers the pair of types of variables? Do you remember having to identify those? Yeah. Yeah, the independent and dependent variable. And they're sometimes called other things like the manipulated variable and the responding variable. And those are actually better descriptions, but much less common in everyday use. So we use the ones that are commonly used, which is independent and dependent variable. The independent variable in any experiment is what you change on purpose to see if it makes a difference. Kind of the whole point of the experiment. If you're experimenting on people, which you are, you figured out, okay, you got to split them into 2 groups. All right. So whatever you're changing from one group to the other group, that's going to be your independent variable. So in this case, Hala, what are we changing from the one group of college kids to the other group of college kids? What's the difference that we caused? Yeah, good. You said that very well. Like some people just say, it's the pill. Well, you didn't really describe anything there. Hala said you gave one half the pill and you gave the other half nothing. You didn't give them the pill. Maybe if you wanted to tighten it up, you could say whether they get the pill or not. Got to be careful how you phrase the independent variable, but that's it. It's you can call it the presence of the pill, whether they got the medication. Okay, but that's what you changed because you want to see if it makes something else change, right? And that is the dependent variable. The thing that you want to see if the independent variable affects, dependent variable. Changes because of what you did. And it's got to be something you can measure. It's the thing I'm measuring, the data I'm taking to see if my experiment is working. That's the dependent variable. That's the easy test. What are you measuring? How do you know if it worked? It's almost always your dependent variable. Those are the 2 you're going to confuse a lot. You're going to, oh man, which one's independent, which one's dependent? I guess the easiest way to remember it is that the dependent variable depends on the independent variable. Then there's a third kind of variable. And that's the one you actually kind of don't want to be a variable. You want your independent variable to be the only thing that's really different between the 2 groups. Everything else you want to manage. And so we call them managed variables. And you did a good job of that. What did you say you wanted to be the same about the 2 groups of college kids? Well, part of it you've already managed just by choosing college kids, right? They're all the same, roughly the same age group, which is great. That's a great variable to manage. Because, right, if your 2 groups are significantly different ages, you're not testing whether your pill works anymore. You're testing whether young people get over COVID faster than old people. What else? What are the variables you want to manage? I think you said some. What were they? Grant, what variables are we going to manage? Where they are, location, yeah. Ideally, we want to put them up in our own facility. What they're eating. Yeah, because if this group over here is eating real healthy and this group's eating crap, you're not measuring whether the pill works anymore. You're measuring whether diet affects your response to COVID, right? We want to manage everything we can. We can never manage all of them. And we're going to have to call that out at the end of whatever paper we're writing, right? We're going to have to say, well, we tried to manage as much as we could, but we couldn't. You know, we didn't have the funding to put them up in our facility, right? Or, you know, these kids are different genetically. We can't help that. We tried to distribute, you know, ethnicities and body types and genotypes in these two groups as evenly as we could, but inevitably there's going to be some differences. Can't help that. But yeah, 3 kinds of variables. That's easy, right? Independent, dependent, and managed. The thing you change on purpose, the thing you measure to see if it works, and the stuff you don't want to be different. Then we're going to take our 2 groups of college kids and we're going to name them. We have names for the groups. Our group that's getting something that is out of the ordinary, something new and different, something experimental, we call the experimental group. That's easy. Obviously, that's which kids? Jack, which kids are they? Which kids are the experimental group? The ones that got the pill. Easy. I bet you know what we call the other group. The group that's there just for comparison. The group that's there to not get this medication so that we can see if the ones who got it get better faster or have better symptoms. What's the name of that group? No? Oh, this is so important. Every experiment has to have this group. Control group. Good. The control group. Got to have a control. Otherwise, you have no idea if your experiment, if your independent variable does anything, because you changed it for everybody. Got to have a group that doesn't get it changed to compare. And by the way, part of any good experimental design is making sure your groups are as large as was humanly possible for your resources. So 100 college kids, pretty good. 1,000 would be better. The bigger your groups or sample sizes are, the more you can trust that your results are valid. So you got to have that control group. And then, but we have a problem. We have a problem with this experiment. I bet some of you know it already. Huge problem with our experimental design right now. And it has to do with the big fat brain thing I told you about how our brains, part of the weakness of our big fat brain is that it's so powerful, it'll sometimes make us believe things we really want to be true. You know about this? So what's the problem? What's going to happen if I give half my college kids a pill and half nothing? What's going to happen that's going to screw up my experiment? Yeah, it's your brains are real powerful. If you all had the cold right now, common cold, and I gave all of you a pill with nothing in it and told you it was a cold treatment, about half of you, and this is again and again, it's so reliable as to be like old hat. It happens every time. About half of you would get better in some way just because you knew you were supposed to. Just because you knew you were getting a treatment. Do you know what that well-known, well-documented effect is called? Good. It's called the placebo effect. A placebo is your pill with nothing in it, right? It's a treatment that's not real. Well, crap, that's going to screw us up because my college kids who get the pill About half of them are going to get better in some way, some measurable way, just because they know they're getting a pill. Ugh. How do we fix that? What kind of pill? You want to give the other group a placebo? So, wait, how does that work?
So the group that you're trying using,
Yeah.
give them the pill that works.
Mm-hmm.
And then the group that you're not trying to use, give them the pill that does not. Has nothing.
It's brilliant, because what it does is instead of just eliminating the placebo effect, it makes it happen to both groups. Both groups, about half of them will show a little bit of an improvement because of the placebo effect, but the same amount. And so any difference now between the two groups, maybe we can attribute to our pill. I like it. What were you going to say? Because there's another way to go about this.
I was going to say that I saw one study and somebody did the same thing, except they gave half the actual pill and half the sugar pill, and people that took the sugar pill hospital was like, oh, I took one instead.
Yep. So the other way, anybody thinking about coming at it from another direction? There's another way to do it. We're just not allowed. You could, yeah. That's it. You could slip it to them, right? You could put it in their food, put it in their drink, and that would absolutely work. That way nobody knows they're getting a treatment. And so there's no placebo effect, right? It's just that the law says you can't do that. You're not allowed to slip people medication without their knowledge. So we got to go about it your way, which is absolutely right. Yeah. So what that's called, by the way, is a single blind design. We are keeping the people that we're experimenting on blind to which group they are in. We only have to do this when humans are involved. But it's absolutely essential. It's not even just with pills. Any experimental treatment, we're going to have to account for the placebo effect. We're going to have some sort of fake treatment for our control group so that the humans involved don't know whether they're control or experimental. They can't know because we know that their brains will affect their outcomes just because they know they're getting something special. It's not just pills either. Man, if I gave half of you an experimental new shoe and said, this shoe, we're testing whether it makes you faster, and the rest of you just wore your old shoes, you guys would run faster if you had the new shoes, just because you thought you should. So we'd have to give you the shoe we were interested in and use some other shoe so that you both thought you were getting the new shoe. Humans are weird like that. Oh, humans are so weird, actually, that we still have a problem. Even with our placebo design, there's still some big fat brains involved that are going to screw up our results. Whose are they? Yeah, yours. You're the scientist, right? If you're a pharmaceutical biochemist who just invented a COVID cure, or you think you did, do you really want it to work? Oh my God, so bad, right? Like, it would make you so much money. You are now very dangerous to this experiment, right? Like let's say Mikey's in my sugar pill group. Mikey, how you feeling? You don't look good. You look like you feel like crap, actually. I'm gonna say, what? You're about a 5 out of 10. Yeah. That's not really recovery. How do you feel? He's in my real pill group. Feel pretty good? You look great, man. You're like glowing, like, right? Yeah, like, you're still sniffing a little bit, but I'm gonna call that like a 9 out of 10, man. Great job. You see what I'm doing? I'm influencing. my data, because I really want her to still be sick, and I really want him to be getting better, because that means my pill works. I got to take that out of the equation. I got to eliminate myself from this. How do I do that? There's a bunch of ways. It's a lot easier than it sounds. You can absolutely hire outside people if you have the budget for it, sure. And they don't even know who's in what group. They're just taking your data for you. Or it could be as simple as with a pill. It makes things pretty easy. I can just have numbered pill bottles. And I keep track on a sheet somewhere, you know, which of my 100 pill bottles has the real stuff and which doesn't. But I don't know while I'm interacting with you guys, right? I don't know while I'm taking data who got what. That way I can at least trust my data taking skills. That, when you take the researchers, the people in contact with the patients, people doing experiment, when they don't know either, that's the ideal design. It's called double-blind design. Super important. That about takes care of it. That about takes care of the problems that our big fat brains introduce into experimenting. So once we know we've got a good experiment, we carry that experiment out, we take our data, we measure our dependent variable. At that point, we start to analyze our data, we draw conclusions. You know the drill here. Last thing we always do is find sources of experimental error, which are always there. Your job is to call those out in your scientific paper before anyone else does, right? You want to be able to say, okay, yeah, we didn't have the funding to hire 1,000 college kids, so we got 100, right? We didn't have the budget to feed them all, so they had to eat dorm food. But their ages are roughly the same. You know, we got them at the same stage of their development of COVID, and that's all we could do. That's an example of sort of identifying your sources of experimental error. They're always there. You just got to make sure you acknowledge that you're aware that those sources of error are there and why you couldn't control them. Questions? All right, I have some practice for you. Got a page of experiments, 5 of them. Simple experiments, some of them designed fairly well, some of them terrible. And part of your job, and some of them is going to be to identify the big problems with them, how they are designed poorly. But mostly your job is going to be to identify in each of these experiments the independent variable, the dependent variable, what variables should be managed, which group or trial is the experimental and which is the control. To help, I'm going to put this up that I skipped over before, just a kind of a quick test anytime you're doing this. A good way to put it is, all right, what's the independent variable? That's the thing. I changed it to see if it would make a difference from one group to the other. That's the independent variable. And the dependent variable is, what did I measure to see if it worked? I'll leave that up to help you while you're working. And while you are working, I am going to be coming around and checking that you have all your materials. Now, it's a long list of materials, so ordinarily I'd just give you a 0 if you didn't have them. I'm going to give you a 0 if you don't have them, but I'm also going to let you bring them tomorrow for 4 out of 5 points. Okay? So we'll go through the list, see if you got everything. If you don't, it'll be a temporary 0 until tomorrow when you bring in all your stuff. I'll write down what you're missing, but it'll be your responsibility to show me the stuff that you were missing. Today, I'm all about second chance. Who'd I miss? Everybody get one? Awesome.